pumps blood. Systole sends blood out. Diastole brings blood in. Systole, heart contracts, mainly the ventricles, to eject blood. Diastole is the phase when the heart muscle relaxes and the chambers fill with blood. These phases alternate continuously to ensure continuous blood circulation throughout the body. The heart consists of 4 chambers. Valves within the heart regulate unidirectional blood flow, preventing backflow. The cardiac cycle is a sequence of coordinated events that occur during one complete heartbeat. Heart pumps blood to arteries. Heart fills, cycle repeats, oxygen flows. Atrial systole involves the contraction of the atria. Atrial contraction tops off ventricular filling, maximizing blood volume before ventricular systole. The P wave on an electrocardiogram corresponds to atrial depolarization during atrial systole. The P wave represents the electrical activity that stimulates atrial contraction. Isovolumetric contraction occurs when the ventricles contract with all heart valves closed. During isovolumetric contraction, ventricular pressure increases rapidly. This phase is analogous to compressing air in a bicycle pump with the valve sealed. Isovolumetric contraction builds sufficient pressure to eventually open the aortic and pulmonary valves. Ventricles push valves open with force. Opening of the semilunar valves allows blood to be ejected from the ventricles into the aorta and pulmonary artery. Blood ejected circulates oxygenated and deoxygenated blood. Isovolumetric relaxation is the phase where the ventricles begin to relax after contraction. During isovolumetric relaxation, all the valves are closed. Closed valves keep ventricle volume steady as pressure drops, preparing for next fill. AV valves open. Atrial pressure wins. Pressure gradient fills the ventricle passively. The cardiac cycle begins with atrial contraction, topping off ventricular volume. Ventricular contraction follows, generating the sound sound as the mitral and tricuspid valves close. Blood is then ejected into the aorta and pulmonary artery as ventricular pressure exceeds arterial pressure. Ventricular relaxation occurs next, producing the STWO sound as the aortic and pulmonic valves close. Finally, the ventricles passively refill with blood, completing the cardiac cycle. Atrial systole corresponds to the P wave on the electrocardiogram and contributes to ventricular filling. Ventricular systole increases ventricular pressure, closing the atrioventricular valves and opening the semilunar valves. Ventricular diastole allows the ventricles to relax and refill with blood. The aortic pressure curve reflects the pressure changes in the aorta during the cardiac cycle. Audible heart sounds correlate with specific valve actions. The SON sound occurs when the mitral and tricuspid valves close. The STU sound occurs when the aortic and pulmonic valves close. Visual cues, such as blinking, can indicate valve activity. Isovolumetric contraction is a phase where ventricular pressure increases without a change in volume. Heart pumps blood rhythmically. This contraction is facilitated by the coordinated action of cardiac muscle cells. Blood pressure is represented by the aortic pressure curve. The systolic phase corresponds to the peak of the aortic pressure curve, indicating maximum arterial pressure. The diastolic phase corresponds to the trough of the aortic pressure curve, indicating minimum arterial pressure. The continuous rise and fall of the aortic pressure curve reflects the cyclical nature of blood pressure during each heartbeat. Specifically, the SON sound is generated by the closing of the atrioventricular valves. These valves close at the beginning of ventricular systole. Left ventricle pumps harder for systemic circulation. The right ventricle pumps blood through the lower resistance pulmonary circulation. Heartbeats, sounds, pressure, health.